Next topic is measures of spread. Now, when we are trying to get the measure of a group of data, we look at its range. Okay, so basically the range is just this, the difference between the highest and the lowest score of a set of scores. Okay, so that's the highest and the lowest scores. The best way to demonstrate this is to do an example. Okay, here's one. If we have this set of scores 7, 3, 5, 2, 1, 6, 9, 8, let's try to find the range of this set of scores. So again, by definition, the range is just the highest minus the lowest score. So therefore, let's look at the highest values. The highest value is 9. The lowest value is 1. Okay, highest value is 9, lowest value is 1. So the range is 9 minus 1, which is 8. So we can say that this set of values has a range of 8. Let's look at another example. Here it is. Let's look at a frequency table where the top row is the scores. So the possible scores are 7, 8, 9, and 10. And the actual frequency is 1, 3, 5, and 2. Meaning for the score of 7, there's 1. There are 3 scores of 8s, 5 9s, and a couple of 10s. Now, when we are looking at a frequency table, to find the range, okay, we are looking at the highest and lowest. So looking at this frequency table, we know that the highest score is 10 and the lowest score is 7. So therefore the range is highest minus lowest, which is therefore 10 minus 7, and the answer is 3. So we can say that this frequency table has a range of 3. Okay, so that's the range. Okay, so just to recap, the range is simply the difference between the highest and the lowest score. Now, let's look at another mathematical term called skewness. I hope I pronounced it right. Skewness. Okay. So basically, what does that mean? All right, let's go back to the values of mean, median, and mode. If these values are very close to each other, okay, any of these measures, like finding the mean, median, or mode, you could use this to describe what we call a central data in a set of data set. Let's look at these two graphs here. Okay, so this graph here and that graph there. As you can see, most scores are actually clustered, okay, clustered around the mean. And in this case, if we look at it, the mean of this graph here is 3, and the mean of this graph here is 3 as well, because all the scores, like these scores here and these scores here, are all clustered to this particular score here, the same as these scores here. And we call this type of graph, okay, is an example of a normal distribution. So what else can we tell about graphs that has a normal distribution or symmetrical towards a particular number? Well, with symmetrical graphs like this, what we could say is that the mean and the median is the same. Okay, the mean and the median is the same. So what happens then when the graph is not symmetrical, like for example this graph here and this graph here? Well, when they are not symmetrical like that, we call this graph skewed. Okay, now if a greater number of the scores are towards the lower end of the score, like this graph here, we say that this graph here is positively skewed. Okay. However, if most of the numbers are, or the scores are all clustered towards the upper end of the score, then we can call this graph negatively skewed.